Alright, now I'm starting on page 11, which is still 7.2 continuation, but it says day 2 reference triangles. So I'll do just one page of this, and then when I come back in the next class we'll pick it up from here. So I will complete this page. So if you can watch this video also, that will be great. So let me again zoom in a little bit. And we can start. So again, this is page 11 from your notes, just the next page. Just make sure that we are on the right page. Alright, there is some notes to be filled in. I'm just going to talk about it a little bit in the beginning and then we'll fill in the notes. So let's see what it asks us. It says, find the exact value of the trig function given that sine alpha is this, and tells us where alpha falls, which quadrant, right? It makes it easy. And cosine beta is this. The value of cosine beta is this, and it tells us which quadrant to fall in. So what we do notice is there are two angles, alpha and beta. They have, instead of just giving us a theta, they have given us two angles, alpha and beta. And if you look at the problems, they ask us to evaluate these things based on this information. So slightly different. We are not splitting an angle into alpha plus beta and doing that. We are doing something different. So for me to evaluate this, for example, cosine alpha minus beta, I will need to know what is cosine alpha as well as cosine beta, sine alpha and sine beta. But what's given to me here is only sine alpha and cosine beta. So remember, going back to unit 1 or unit 1 in trig, when we did the first unit in trig, given a ratio, if I know which quadrant it belongs to, I can draw my reference triangle in the correct quadrant, find the missing side, and find all the trig ratios. You guys remember that? So I'm going to go ahead and do that just for the one triangle. So it says sine alpha equals pi by 13, and it tells me that alpha is between 0 and pi by 2. So let's go ahead and write this down. So what does this mean? Alpha falls between, in my first quadrant. Can everybody see that? Between 0 and pi by 2. So I'm looking at the first quadrant, which is this. And this is alpha. So normally I would put a theta, but let's be mindful and put an alpha here. So I'm looking at sine alpha. So I'm looking at alpha angle, and sine alpha means opposite by hypotenuse. So opposite is 5, hypotenuse is 13. And for me to find the missing side, it's what is that? 5 square plus missing side equals 13 square. Please go ahead and you can hit pause. Find the missing side. I don't think I need to work on this with you, and you will find the missing side to be 12. Because this is first quadrant, everything is positive. Otherwise, please make sure that you put the correct signs. Pythagorean theorem will not give you the correct signs. So now that I have enough information to write down all the trig ratios, sine is already given to me. I'm just going to write it down, even though it's given to me. But cosine I need. Cosine is adjacent over hypotenuse. And tangent is, sorry, it's cosine alpha, I shouldn't forget. And tangent alpha is opposite by adjacent, so 5 over 12. It's written a little small, but hopefully we can all see it. You can expand it if you need to, but hopefully we have all the three trig ratios for alpha. You will do the same thing for beta. Beta falls between pi by 2 and pi. So that is my second quadrant, right? Pi by 2 and pi is my second quadrant. So I'm just going to go ahead and just make this as a... Okay, I'm going to let you guys hit pause and see if you can use these two values, adjacent, hypotenuse, find the missing side, and write me the three trig ratios. And when you're done, you should see what I'm just filling in. So this one is right. Once you find the missing side, sine is opposite by hypotenuse, and this will be positive because it's on the positive y-axis. Cosine is already given to me, but I will write tan also. The reason I'm writing tan is the last question is tan alpha minus beta. So we need to know the tan value also. So tan beta is opposite by adjacent. So so these are my two reference triangles. I'm just going to there are two different reference triangles. One is alpha, one is beta. So this is again going back to the first unit we did, the unit circle, where given information of a reference triangle, given a ratio, we can draw the reference triangle and find all the three trig ratios. So now that I've started this, I think I can fill in these notes. So for us to do this, the strategy is draw a reference triangle for two angles in the appropriate quadrant. This is important, right? You have to figure out the quadrant because the positive and the negatives will change. Label the two sides. So like for example, even in this case, you made this to be negative because this is on the negative x-axis. Label the two sides using so, ka, toa. Find the missing side using Pythagorean theorem. And then you have all the three trig ratios, or 6 in some cases, as you need. In this case we need 3 because we're talking about cosine alpha minus beta and so on and so forth. Okay, so let's start. So cosine alpha minus beta, first thing I'm just going to expand my formula looking at the formula sheet. So my formula sheet says cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. So what I'm going to do now is, now that I have this formula, all I'm going to do is look at the two reference triangles and look at the sine and cosine, alpha and beta values and substitute. So cosine alpha, please look at the alpha, that's 12 over 13, the first triangle. Cosine beta, look at the second one, is negative 3 over 5. Sine alpha, so I'm at alpha, so I look at sine, 5 over 13. Sine beta, I look at beta and look at the sine, 4 over 5. Now it's just a matter of doing the math. Remember, multiplying fractions top to top, bottom to bottom. 12 times negative 3 is negative 36. 13 times 5 is 65. 5 times 4 is 20 over 65. Now I'm looking to add fractions. Luckily for me, this fraction addition has a common denominator. So I will just write the common denominator and just subtract these two because this is negative, this is positive. That's it. I feel the main work in such a problem, in this kind of a problem, is this. Making sure you draw your reference triangle correctly. Hopefully if you remember the first unit that we did in Trig, if your foundation is strong, you will do okay in that. And then it's just a matter of substituting it and finishing it up. Okay, I'll go ahead and do the other two. It's the same thing, so I'm going to go ahead and do the other two. So I'm just going to give you guys a couple of seconds just to absorb this. Alright, so I'm just going to go ahead again, write the formula, substitute, finish it up. So there's not much talking for me to do. This is coming from the formula sheet. Now I'm just substituting from the alpha and the beta. And then just doing the math. And common denominator. And I just subtract these two. So it's positive because 48 is positive. That's it. Pretty straightforward, right? Like I said, if you got this concept correct, this here is just a matter of using the formula sheet and substituting in the formula. This tan can get a little more trickier just because there is a numerator and a denominator in the formula, and when you substitute, the numerator will contain a fraction, the denominator will contain a fraction, so you're talking about a complex fraction that you want to simplify. So anyway, let's first write down the formula. Substituting now from my tan values from alpha and beta. So tan alpha is Okay, I'm going to keep working on this till I feel I need to. So this is nothing but, I'm just rewriting it. This, first of all, becomes negative because one of them, I multiply these two. 5 times 4 is 20 over, remember, multiplying fractions top to top, bottom to bottom. So basically what I can do is I can combine these two fractions and write it as 1 and then do the whole keep change flip. Another way to do this is, I would like you guys work on this by yourself, but there are different ways to do this, right? You can multiply top and bottom by 36, combine this and get one fraction, and combine this with multiplying top and bottom of this with 4 and get one fraction and do the keep change flip. Or you can multiply top and bottom with the common denominator, which is 36. But basically you'll get this. So whichever method you do to simplify this complex fraction, you should land up with 63 over 16. I'm not elaborating it too much because I think there are different ways to do this. Maybe if you still didn't get this, maybe when I see you in class, next class, I can elaborate how we go from here to here a little more. But I want you to try, because we have done complex fraction under rational functions. So I need you to think about it and see how you can simplify this to get this. Alright, so we will stop here.